Okay, looks good. So let's get started. Hello, everyone, and welcome to today's Better Buildings webinar, dedicated to bringing you the latest actionable insights from leading industry experts. Better Buildings webinars are a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate decarbonization and energy efficiency adoption. Next slide, please. There we go. Today's webinar is called Where Are They Now? Success Stories from Early Adopters of Advanced Lighting Systems. Before we dive in, there are a few housekeeping points I would like to cover. First, attendees are in listen-only mode, meaning your microphones are muted. Secondly, if you experience any audio or visual issues throughout the webinar, please send a message in the QA box located on the bottom of your Zoom panel, and our tech support team will be in touch. And finally, today's webinar will be recorded and archived on the Better Buildings Solution Center. We will follow up when today's recordings and slides are made available. Next slide, please. Speaking of the Better Buildings Solution Center, we encourage you to stop by if you haven't already. It offers over 3,000 resources to help you decarbonize and upgrade your buildings. Go to betterbuildingssolutioncenter.energy.gov to explore the latest news, tools, and strategies it has to offer. Next slide. So, my name is Corey Strawn, and I'm a systems engineer here at Pacific Northwest National Lab. I work on several lighting-related projects here at our Portland office, as well as other building systems projects across the lab, and I'll be serving as your moderator for today's webinar. On the next slide, we should have an agenda for you all. Yes, perfect. So first, we have a quick introduction of the ILC, followed by an overview of today's discussion and an introduction of our guest speakers. We'll have a few welcome polls to get you all used to using Slido if you've never used it before. Our speakers will share their presentations, and finally, we'll conclude with a question and answer session and closing. Next slide. Before we jump into the main presentation, I want to tell you about the Integrated Lighting Campaign, or ILC for short. The ILC is a recognition program that accepts submissions of advanced lighting projects and recognizes successful projects that save energy and improve lighted spaces for all. We really like to see integrated lighting projects, which in this sense, integrated means that the lighting controls work with other building systems to enhance overall building performance. These systems have the ability to relay useful information to these other building systems, like occupancy information, ambient light, temperature and humidity, and location of assets. We also recognize advanced systems and controls in lighting that improve lighting performance and go above and beyond simple on-off switching, with capabilities like occupancy sensing, daylight harvesting, high-end trim, and scheduling control. Today, we will hear from two projects that received recognition in the first years of the campaign, and we'll get an update on how their systems have been performing. Next slide, please. So where are they now? Throughout 2024, we revisited some previous recognized ILC projects. We wanted to assess how these systems have performed in terms of energy savings, their reliability, and their cost effectiveness, and noting successes and challenges will help the ILC better prepare future installations of integrated lighting. We asked managers of two successful projects to join us today to share their stories, as well as a P&L expert to talk through some of the challenges. Next slide, please. We have a great lineup of presenters today. Going from left to right, first we have Adam Hutchinson. Adam Hutchinson has served as the energy management specialist at Denver Water for the past 7 years, and he plays a key role on the sustainability team. His work focuses on leading energy efficiency initiatives, reducing greenhouse gas emissions, and driving renewable energy generation across the organization's operations. Next in line, we have Kenny Seaton. Kenny Seaton is the Director of Central Plant Operations and Strategic Energy Projects for Cal State Dominguez Hills and has occupied that position since February 2011. He currently manages a team of 11 employees responsible for the heating, cooling, and maintenance of approximately 1.5 million square feet of classrooms and office space on campus, as well as central plant equipment. And then last but not least, we have Michael Meyer. Michael Meyer joined PNNL in 2007 as a lighting researcher. He currently supports a variety of programs at DOE focused on the commercial and federal adoption of high efficiency lighting equipment and controls. Thanks to you all for being with us today. Next slide, please. So, Slido. Today we'll be using an interactive platform for Q&A and polling. Please go to www.slido.com on your mobile device or by opening a new window in your internet browser. Today's event code is #DOE. Again, that's #DOE. If you would like to ask our panelists questions, please submit them anytime throughout the presentation. We'll be answering your questions near the end of the webinar. You can select the thumbs up icon for questions that you like, which will result in the most popular questions moving to the top of the queue. Next slide, please. Cool, so we want to learn more about you. So let's start off with a few polls. Please join us over at Slido to respond to the following questions. If you have any issues, please message our tech support team by using the Zoom Q&A function. So if we can go ahead and transition over to Slido. There we go. So where are you calling in from today? I see we already got quite a few places coming in: Seattle, Chaska, Colorado, Fairfax County, Virginia, Pennsylvania, front and center. Love it. Chicago, Denver. It's moving around so much. New York, Pittsburgh, Virginia. Someone's home office. That's hilarious. I'm also currently in my home office, so you're not alone. Missouri, Florianopolis. That's a new one for me. Iowa, Memphis, Carlisle boys, #DOE. Have the entire United States online right now. Love to see it. Still have a few more participants typing. Baltimore, Colorado, Washington, and Washington, D.C. Connecticut, Oregon, probably right down the street from me. Vancouver, Nashville, nice. Maryland, Montana. Again, thank you all for joining into today's Better Buildings webinar. So excited to have you all here with us today. Spain. Okay, on to the next question. Are you considering upgrading your facility's lighting? So we have answers for yes. Oh, we're starting to get some coming in. So we've already upgraded. We have yes, we'll upgrade to LEDs and controls. No plans to upgrade. Yes, we'll upgrade to LEDs. Or yes, but I'm not that far along. And then there is one more at the bottom. You might not be able to see the actual progress on it, but yes, we'll upgrade to LEDs and integrate the controls with HVAC plug loads or other systems. Currently at the top of the list, we've already upgraded. Really nice to hear. Hopefully you all find today's information from our guest speakers very useful to your own projects, and you're able to have some takeaways from that. Nice. Still at the top of the list with 28%, we've already upgraded. Okay, it's looking good. I think it's starting to level off here. Topping off at 30%, we have already upgraded your facility's lighting. Very good to hear. Give this just a few more moments before we transition over to our first guest speaker. Yes, we'll upgrade the LEDs and controls, coming in as a runner-up. Okay, it's looking good. And with that, I will hand it off to Adam to kick us off. Take it away, Adam.
Thanks, Corey. Just want to make sure my video and microphone are working. Looks like it. All right, next slide. Okay, integrated lighting controls 2 years later. Once again, thanks, Corey, for kicking this whole thing off. That was really cool with the Slido deck. I hadn't seen that before, so I really like the location-based one. That was I saw a lot of places that I've actually been to, so that was cool. Yeah, so thanks, and then thank you to everybody that's on the webinar. Thanks for tuning in. Just to hear how our integrated lighting controls have been operating in the last couple of years, seeing what value we're getting out of them, and how we're working to make it even better. Next slide, please. So just in case you weren't present 2 years ago, or my presentation isn't seared into your memory if you were there, I'm going to kind of give you a little bit of a background refresher on the project itself and how we used integrated lighting controls as part of our operations complex redevelopment. Next slide. So just describe these real quick. We have a 35-acre campus in downtown Denver. So the kind of the drawing on the right, that's a representation of actually how our campus was redeveloped. We built 9 new buildings on this 35-acre campus. They're all either LEED Platinum or LEED Gold. And then the picture on the left there is just a drone shot that kind of gives you a view of the campus from above, with our admin building, which is the building I'm going to be focusing on today, in the foreground there. And then you can kind of see it's kind of a long, narrow campus, and those rest of the buildings that are on the kind of the picture on the right, you can kind of see them in reality on the photo on the left. So let's move to the next slide. All right. So like I said, the energy measure we're talking about today is integrated lighting controls. And they're installed in our main admin building on this campus. So this building hosts the majority of the employees at Denver Water. So we have about 1,100 total employees, and about 600 of them either work out of this admin building or deploy out of this admin building. And I'll kind of give you just a breakdown. This is kind of how we present this story. The Water Admin Building is a LEED certified as office building space. And it has a networked lighting control system that's BACnet integrated with the building automation system. So our LCS, lighting control system, and our building automation system, BAS, are BACnet linked together. And they share actually the occupancy sensors from the lighting system shares real-time status of the lighting, or actually the occupancy in the space. And this is actually the case for almost every single space in the building. And from this, we get, of course, energy savings from decreasing HVAC loads as well as lighting loads. And I do also want to point out that HVAC loads, when they're for occupied and non-occupied spaces, just to give you the set points here, for cooling, we're at 76 and 85. And for heating, we're at 70 and 60. And let's move on to the next slide. Okay, so the cool thing about this project with the integrated lighting controls is that it was a new build. And I know that maybe not all of you are going to be able to do this. This was a project that was a long time in the making and took a lot to actually pull off. But this was a new build, and we got to mesh these controls in with a lot of other energy saving design strategies. So I just wanted to give you an overview of everything that's going on in this building, because you'll see some trend charts later that that show actually a lot of big savings. And it doesn't all come from integrated lighting controls, but I found them to be extremely valuable and very helpful in our process. So we have solar panels on this building. Let's see, our heating and cooling are radiant, and that is also tied to a central utility plant, which is extremely efficient. We have a highly insulated and non-infiltration shell, which has been fantastic. We have a dedicated outdoor air system for ventilation, which actually saves a lot of energy too. And that kind of works in conjunction as well with the integrated lighting controls. So I just wanted to give you kind of an idea of everything that's going on here. There's some other things listed on this slide. Sorry if you can't read them, but hopefully we can share this up too. And I also wanted to tell you that, so the admin building itself, we only did the integrated lighting controls in this building on this campus, and there were kind of three reasons for that. First, like I mentioned before, it's the most occupied facility in Denver Water's facility list. So we really saw a benefit for controlling these spaces based on occupancy. Second, the rest of the buildings on this campus, and we're talking like fleet building, warehouse, trade shop, meter shop, we have some storage. So all those serve really specific needs for the operations, for the actual teams that are working out in the field and whatnot. And we found that those benefited from more of a scheduled kind of scheme for controlling HVAC and lighting. And then third, and I don't know if it's maybe not the most important, but we actually set a goal for the admin building to meet net zero energy. And we're meeting that goal right now. So we were looking at pretty much anything and everything that we could to increase energy efficiency before we put renewables on to actually be able to get our net zero energy goal. So let's move on to the next slide. Okay, so with all that background information, hopefully that was pretty clear, we can now move into the actual operations and see how well the system's been performing. So let's go to the next slide. So, okay, this is pretty much our energy savings in chart form. And what you're looking at here is we have the campus energy use on the left side, the kind of aqua blue charts there. And the top one is electricity, bottom one's natural gas. I should also point out that the admin building is fully electric. There's no natural gas used in that building. We do have a backup heater for our central utility plant that's natural gas that only operates, I think, below 2 degrees, I believe. It's 2 degrees or 5 degrees Fahrenheit. And then the charts on the chart in the table on the right, that's actually our admin energy tracking. So this is all electric use. And then you can also see it in the table there. That's our energy use intensity for the last 3 years. So just from this, I just want to kind of, I know the numbers are really hard to see and they're kind of small, but I just wanted to give you kind of the scope of the energy savings that happened pre-construction and then actually post-construction and what was going on here. So you can see that the entire campus, we're looking at, we pretty much cut electricity use in half. Same with our natural gas use, and that's decreasing every year as we're finding more efficiencies and more efficient ways to actually keep our buildings operating. And then if you look at the admin building total, I guess I should mention this. I think many people kind of went through this. Substantial completion was in November of 2019. So we all moved in and we were happy as could be. We're sitting in our brand new building. It was wonderful. And then of course, COVID hit and we all left the building in March of 2020. So it was kind of interesting. I'm sure a lot of people dealt with it, you know, how do you operate your buildings? What's going on? Well, we were dealing with a brand new building that we hadn't even got to live in for like 3 or 4 months. So it was a really interesting time. So, you know, also see that 2020, very low electricity use compared to the other years. And you can see it kind of creeping up with more and more occupancy through 2022 and then 2023. And one thing I'd like to note here is I mentioned the new net zero energy goal for this building. And one thing that I'm really excited about with the integrated lighting controls and HVAC and lighting is that at some point, our solar panels produce 1.2 million, a little bit more than that. We're closing in on 1 million kWh of use in the admin building. So at some point with degradation and whatnot, our solar production is going to be probably lower than our use. So I'm looking at ways that we can actually increase efficiency in the building, and the integrated controls are definitely part of that plan. Let's move on to the next slide. Okay, so the next couple of slides, I'm just going to talk just kind of specifically about the lighting and the HVAC controls. So of course, LEDs everywhere. Our lighting design, you know, 0.5 watts per square foot. That was pretty low. It's a really well designed building for energy use. And I also want to say a couple different things about using the system and driving kind of savings through it. We can look at a lot of different things with this system, and it's kind of something I think we overlooked in the first couple of years. You know, we can trend occupancy data, we can trend daylighting levels in the system, we can trend light levels, not opposite or not opposite, but different from daylight levels. We have all sorts of different ways that we can actually, and strategies that we can employ to save energy. And I also want to mention that we really, if this is something that you're looking at doing or that you've already done, is really got to engage with the occupants in these buildings. When we moved in, we only had 3 or 4 months. Everybody came back in 2022, basically. And a lot of people didn't really understand that the occupancy sensors from lighting controls were actually controlling both the lighting and the HVAC. So some people were not sitting in the dark, for days on end, but the occupancy sensors wouldn't work because they were either blocked by some piping or some diffusers or something like that. And they did not know exactly that they could call in and be like, hey, you know what? I don't know if I need to turn lights on every 15 minutes, and it's a little bit cooler in here than I think it should be. So that's something I would just like to bring out, is that you really have to tell your occupants, hey, let us know if something doesn't seem like it's working, because we can probably fix it pretty easily. And then I just want to point out, we've done some studies, you can kind of see here in this kind of chart on the right, this would be our baseline on the very top. And where that red is, that's normally when all the lights would be on during like a scheduled operations. And you can actually see the savings then down on the bottom row there. So we believe we're saving about 80,000 kWh a year just in lighting savings with occupancy controls. And let's move on to the next slide. And then central utility plant. This is, so I'll talk about the HVAC savings that we're seeing here. So I don't use this system nearly as much. So I had our HVAC techs kind of help me out with this. And we had to go through a bunch of data. It's a very interesting system they have it, but it's also, like I kind of mentioned with the lighting system, you can print all sorts of information. It's very, very valuable that we found. We did find that the largest savings are actually coming from reduced cooling load, not so much from the heating load. And I think that's a lot of to do with the actual design parameters that they laid out in the very beginning, where they were thinking the building would be occupied, 6 a.m. to 6 p.m. Monday through Friday, maybe half the people on the weekend. And of course, after COVID and all the hybrid schedules and everything like that, it's been a little bit different. So I know the design was actually planning on people heating the building and machines and switches and all that stuff. So I think that's why we're seeing a lot more savings with the cooling than we are than the heating. So I actually had the techs kind of help me out here with all these numbers, and we have a BTU meter that comes into the admin building. And of course, you can see from here, we're saving, we think about 120,000 kWh a year just based on the occupancy with the HVAC system. So total, we're about 200,000 kWh every year in savings, which I think is fantastic. Based on our EUIs and everything like that, we're going in the right direction, and I think we could even get a little bit better on that. So next slide, please. Oh, and just real quick takeaways. I just want to say, don't silo the stakeholders. Get everybody in the room together at the very beginning if you can. Trades, IT, facilities maintenance. We've really seen this kind of we've seen benefits for sure. I just want to let everybody know that we think this system's been great, and we're excited about the future savings that we think we can get out of it. And I also did want to say that we do have a facilities maintenance team that I think last time, if you were here 2 years ago, we were talking about implementing. And then also we did do this strategy at our newest treatment plant as well. Not the exact same system, but we use the same strategy. And we kind of see this as, if we're going to do high performance buildings, this is going to be part of our strategy moving forward. So next slide. Yeah, that's my update for today. Hope that was helpful, and keep up the good work, everybody, on energy efficiency. Thanks.
Thank you so much, Adam, for sharing that with us. And next, we will have Kenny, otherwise known as Kenergy. Take it away.
All right, next slide. Hey, thanks for having me. First of all, great job, Adam, for having a net zero building. Every time I see one of those, I'm excited. Next slide, we'll get right to it. All right, so where we were was we started off in this particular building. This is our administration building. I've got years and years of data on this with power meters and stuff, and so I didn't go back before 2019, but that graph looks the same. COVID hit 2020, we dropped down, but at the same time, we were in the middle of doing a fluorescent to LED with smart control upgrade. And the power just kept going down. You can see the top one is KW and the bottom one is KWH. So KWH is what we pay for. Let's move to the next slide. So this is another building. Once we got those results, then we just pushed for people say, how did you pay for it? A couple of these were done with EPIC grants. Some of them were done with rebate money. Some of them were just found because it was the right thing to do. We started off in the beginning with 4 sensors outside the IT suite. You know, if this stuff's going to work, then we're going to put it here in the C suite outside of IT. And we just kind of kept expanding it every year, a little bit at a time until we proved concept. And then they started giving us money to do all of it. So here again, LaCourte Hall, savings that kept going. Let's go to the next one. Another building, SBS. So, and I'll preface this that all these savings are not just because we're turning the lights off and on, which was huge, but it's that what Adam said, we're turning off the HVAC, right? So we're not cooling spaces that don't have people. We have to stop sending energy to where it's just wasted and not being used so that we can use it more efficiently. Next slide. So this is kind of a visual that explains that, right? So this was during COVID. This was the 4th floor of our admin building. There was 7 people probably in this space. The president, the vice president, the provost, a few people. And so looking at the heat map, that's actually motion sensing. Those are the only places that had lights on and the only places that had HVAC. If we can prove that nobody's in the space, we were able to close the damper to 0. We would still do our flushes in the morning and the evening for COVID, but in the middle of the day when there was just 7 people there was no reason to be pushing air into all those extra spaces. Next slide. So if you don't know, the way HVAC works is that there's going to be a damper that opens and closes and sends air into a space. If it's a large space, like a conference room or classrooms, there's going to be 1 VAV for the entire space. But for offices, due to budgets, you're going to have 1 VAV for probably 3 to 5 offices, which means 1 person will be in control of the thermostat, but that's a whole nother story. But how do we know when somebody's in the space or not, right? So you have to do it with the smart lighting, right? So now the lighting says, hey, look, I know nobody's in this space, this space, this space. We're able to map that to 1 point. We'd label that point the same as we would with the VAVs or for our HVAC system. And then we get a point back and it's just tied into the thermostat controls for occupancy. You can do setback if you want. If it's a southwest facing office, then you're not going to shut the damper all the way. You're going to do, you know, a different temperature so that you can catch up. But in so many spaces, you actually can set it all the way back. One of the things that Adam said that's so important is that engagement, though. So when we do these buildings, I or one of my team members would walk around to every single office and walk in and say, hey, where would you like your lights? And first of all, people are just blown away because they can't believe that you can do that. For those that haven't done it, or some of you that have done it, a lesson learned was don't start at 100% and turn lights down. Start at 20% and turn lights up. So 20%, 25, 30. How's that? You like your lights there? And then you might end up at 40. Some of these buildings, when we put the LEDs in, we pretty much 40 was kind of an average. everybody is happy. Now you can set lights so that they don't go on at all if people walk in, because a lot of people, we're finding out have light sensitivity, right? So, hey, look, you know what? Your lights won't come on, but if you need them on to do collaboration, go push the button on the wall and the lights will go on for till you time out or turn them off, right? Because we're having sensors on all the fixtures, we're able to get away with shorter timeout, 7 minutes. So we don't have, the old school days where you had 30-minute and 1 hour where they just were broken and didn't work. It's super exciting for me when I walk by my buildings at nighttime now, because I'm that nerd that comes in at 1 o'clock in the morning to see, oh, look, it's all dark except for my exterior lights. Next slide. So some of the lessons learned. It's going to reside on your IT network. Make friends with your IT. Buy them lunch, do whatever you have to. If you haven't done the project yet, or even if you have one and you're going to do another one, invite them in early. Have them sit down at the table and ask those questions, so that it's not you that says, hey, we're going to do this project and I need you to make it work. Instead, it's, hey guys, can you work with us so that we can figure out how to make this work? That way you'll get them to buy in and they'll be excited to try and help you, hopefully. If it's a new system, ask for references of people that have done the integration. There's a lot of systems out there and we're still figuring it out. BACnet can be painful, right? And so you need to make sure that you're not going to overload the system, that you're not too many whois commands and that kind of stuff. Create good backups of your BAS, your building automation system, and your lighting server. Don't rely on the vendors. Hopefully you're backing stuff up every night, and that way if something goes wrong, it's really quick and easy to just refresh, reload from yesterday, especially if you start managing this yourself. Make sure the installers and integrators know their roles and responsibilities. That's a huge thing. Now that I have this is a campus standard. So we built 2 new buildings right around COVID time, and that was the standard, was it had this system in it. The lighting guys were pointing their finger at the controls contractor saying, hey, it's your job to bring these zones in. The controls contractor said, well, you didn't create any zones. There's nothing for us to discover. And then the problem is that you'll have an electrical contractor that is told to, hey, I want this system put in. They don't know anything about it. And so you have to have some pretty thorough conversations in the beginning. And there's people that can help you with that, or scoping documents. But you need to make sure that the people know what they're doing. You're buying a very sophisticated system. And at the end of the day, it turning the lights on and off is not enough. And I've seen them try and get away with that. So, oh, well, we'll just do the hallways at 100% with, we'll group it all together and it's one giant sensor. And I'm like, well, yeah, but people come in from different sides. Why do I need that much light? 10% is enough light to walk down a hallway, depending on the light fixtures and stuff. 40% is enough to stand there and have a conversation. And then after a minute of no movement, the lights, dim back down. So you can be pretty aggressive, and people don't know. Again, know what the system's supposed to do, so that everybody has the same expectations. Next slide, please. So my closing slide, it might be painful. It's going to take time to do it right. Don't think you're going to be able to just, scope, okay, we're going to do this, this lighting thing. You need to get involved. But once it's finished, it is so worth it. I could never imagine running a building that didn't have occupancy-based controls. Every building that I've done it to that was a retrofit uses 50% less power than it did before. And that shows on some of the slides. And I was curious, so I put this slide together. Everything I have is in SkySpark, all my energy data, all my occupancy data, all my points. And so the blue is what it cost me in 2019 before the retrofit. The purple is the cost of doing nothing, right? If we had done nothing, it would have cost me that. And the green is what it actually costs now. And so you can see that the rates started off at 12.5 cents and went up to 23, 24, 26 cents. We have to try and stay ahead of it, right? Just reducing the kWh, turning the lights off is not enough, right? We have to push the needle as far as we can. The graph at the top is just that's the Welch Hall building that's doing half as much. The the power went up when we did the retrofit because now we're running the building 24/7, right? Like, hey, it's hot in here. Can you turn the air conditioning on? I never ran it at nighttime before. And so then you see the fixtures got installed and then we started task tuning them. Then people stayed at home. And then while everybody else was at home, the facilities were there. And that's when we started integrating into the BAS and seeing the huge savings. And just like Adam had said, the cooling savings is where it's at, right? The lighting's great, but shutting down your chiller plant or not having to start up a second chiller because you just reduced your occupancy by half is huge. Next slide. And that's it. Thank you. Again, think about it. If better is possible, good is not enough. Let's all keep pushing the envelope.
Thank you so much, Kenny. Very insightful information. So I appreciate you for sharing that with us all. A quick reminder to our audience to send any questions you have at www.slido.com with event code is #DOE. Again, that's #DOE. We look forward to answering your questions at the end of the session. And now we will hear from our final speaker, Michael. It's all yours.
Thank you, Corey. And can we move on to our next slide? So I feel bad. I'm the one who has come back in and maybe grounded a little bit. I think Kenny and Adam did a great job discussing the benefits and the advantages to it. I'm here to do some more lessons learned and some of the challenges. I still think this is a great technology. I think it should totally be pursued. But we did a bunch of different projects and early on and learned some of the hard stuff early and just wanted to share that. And so that's what it is. So again, while I might be sharing some of the challenges that P&L and others have seen with this integration, we are trying to show you how to identify those challenges and move past it so you can have the success. I very much applaud Kenny and Adam's work, and I think the savings they showed are great, and it's why you should lean into it. And we're working to address some of those challenges and make it a more standard practice for everybody. So first thing is, as Kenny alluded to, you're going to be talking to IT, your networking. It's no longer an isolated system. So things you need to think about. You don't actually have to put the light sensor in the fixture. It just makes a lot of sense. You can put a sensor out there elsewhere. One reason mechanical engineers actually like having the occupancy sensor as part of the fixture is that the light turns off so they know the sensor is working. When mechanical engineers have said, well, when the occupancy sensor is standalone to the mechanical system, they actually don't know if there's a false positive or anything else because it's just reading a signal and it's feeding back to the mechanical system. But when it's integrated to that light fixture, they can have a visual detection, as Kenny alluded to. When the light's off, they know the signal, and therefore they can make sure that it's coming through on the mechanical side. This is the back of a rack. You're definitely going to communicate, and we'll talk about some of those challenges. And then zoning matters, and Kenny also talked about that briefly. This is where you're starting to have trades talk to each other, and you're going to hear some of the challenges with that in a second. But this is also something to think about. Even if you integrate a sensor in every fixture, your coverage is not always perfect. And for instance, there's some places where you can't put a sensor in every fixture because it's decorative or a downlight or some other reasons. You may have to have a few standalone fixtures. This is an example of an open ceiling where they just put the sensor built into a J-box. So there are novel solutions that teams can come up with, but you may have to solve those. Next slide, please. So as I mentioned, one of the challenges we had on this project here was zone mapping. So this is really about making sure your project team is on board, they understand the tasks, and they want to be a willing participant. I think if you pull people begrudgingly into it, you don't always get their best efforts sometimes, and they set up some challenges. So this is an example of a mechanical engineer basically was quoted, the mechanical contractor in this case, quoted the project team over 300 hours to map all the points and then take the information from the mechanical system and the lighting system and to communicate. This is an outlier. You can do this with a lot easier work. Some people can do it themselves on site if you're very knowledgeable about your building and you're willing to lean into a little bit of the lighting. There's also system integrators out there who do this, and they're familiar with talking both sides, the two different technologies. So it can be done. But the first thing is you need to be specific in your work orders. What are you looking to be done? It isn't just make it work, because when you ask someone to just make it work without specifics, they tend to throw everything at it just because they're trying to manage their own risk in the making it work. Next slide, please. So along the way, communication is important. So as Kenny alluded to, their whole project changed because of COVID. So this is a project that Pacific Northwest was managing with the U.S. General Services Administration. They're the kind of federal landlord. They have about 300 million square feet of space. 2019, we were up and rolling. And then all of a sudden, as most of the world knows, 2020 and the pandemic changed everything. So in the middle of while we were trying to do this, the mechanical team, this is a 30-plus story high rise. And the mechanical team and the project team weren't always communicating on a daily basis or on a weekly basis to know what each other was doing. And the mechanical team changed the JACE on us without us knowing. And that caused a communication gap. So that's an example of you want to be communicating. So while you might have a group of people who are really forward into technology and really wanting to integrate, and then you might have other people doing standard run-the-mill maintenance, and then some small change happens, and two sides are not saying, oh, well, I didn't know. As a result, when the JACE replacement happened, it actually caused a communication error, and then we found out a port address issue. We ultimately got it all fixed, but this is an example of when you're starting to do integration, you do need more people talking to each other. You're taking that lighting information and you're pulling it into the mechanical system, so more people need to talk and know how it's working together. We ultimately did have to stop this integration more because we need to refocus people on the COVID protocols and those type of things. Next slide, please. The other challenge that we found at one of our projects was the University of Minnesota were advanced users. They have a great campus, and they actually have unique port names for all of their BAS through BACnet, which is a little more advanced than many sites. And so as a result, what happened was the lighting vendor was used to traditional BACnet, and the lighting vendor couldn't actually communicate with these new BACnet ports because of the unique naming that the University of Minnesota had given them, which makes sense. They have a large campus and they wanted to manage every building through a central location, so everything had a unique name. Ultimately, there was a challenge, and so the lighting vendor had actually shipped the equipment back to their manufacturing facility to update the firmware, then bring it back on site. So something also you're going to want to think about is, as Kenny alluded to, you are going to need to make friends with IT, but IT security doesn't always want to let everything on the network. And sometimes that might mean, how are you pulling firmware and system updates? You can sometimes do that with just a drop-down cellular modem that you can bring in from the outside and directly connect to your system. But it is something you need to think about is, how is your system going to be updated, and how is it going to potentially call out to the rest of the world if it needs to download a firmware update? That usually is your lighting system that's needing to do that. So something to think about. I would also kind of encourage you to look at DALI, the DALI 2 protocol. It's a digital standard. They are actively working with, having conversations right now with BACnet, the organization that manages BACnet, about interoperability. And why that matters is that once we move to digital protocols and lighting, and we have this friendlier relationship between communication across multiple platforms and protocols, some of these issues will also get resolved in that work the other groups are doing. Next slide, please. So we've talked about kind of your network design. We've talked about your communication with BACnet. Not every building is going to be perfect for integrating with lighting. So I'm going to talk about 3 projects here. One of them, again, is this high rise in downtown Chicago. Why is that important? Is that we'll talk about the air handlers. Then we're also going to talk about some of the limitations at an outpatient clinic. And then finally, we'll talk also about why mechanical systems really matter, and you can't just run around integrating everything. Next slide, please. So as I mentioned, this building in downtown Chicago, it's done by the famous architect Mies van der Rohe. It's about 35 stories tall. And as a result, it was built in the 60s. They had air handling units that were serving multiple floors. And then they had these perimeter units along the windows. Why that matters is that if you're trying to use an occupancy system to communicate with your mechanical to start doing setbacks, if your air handler is serving multiple floors, it doesn't really matter. You can't really, unless every floor is empty, and then at that point, is the occupancy control really working, or should it just be a schedule-based approach? So essentially, you really need to think through your mechanical system. You really want that variable system, and that's what matters. These large, older designs where they're just feeding lots of space while that may have been a benefit at the time for a cost or efficiency, when you get into the variable systems, they just aren't as variable. They aren't as flexible. And so that matters. The other challenge we had was the perimeter system was essentially not communicating with the larger system, and it was defeating some of the things we were doing, essentially increasing temperature when we were decreasing and those type of things. So again, you need to think about how your systems work and how they're going to work together through your sequence of operations. Next slide, please. Another challenge that we talked about, and it was mentioned briefly in the earlier presentations, was BACnet. BACnet's pretty standard for a lot of mechanical systems. It's not the only communication protocol. However, mechanical systems have fewer objects, and objects is a technical term within BACnet, but we'll use it as the broad term here. And as a result, when this project introduced all the light fixtures and all the sensors into the BACnet network on site, they crashed the network because it wasn't designed to handle that many elements. So that's definitely something you need to think about. And again, I'm going to point to this Dolly BACnet working relationship that they're working on, because as BACnet starts thinking about, hey, we might be talking to other systems, they're going to start looking at, well, how does lighting need to communicate? Because the protocols you need for lighting and mechanical are very different. So all the attributes and those things need to change. So the key thing is, if you're doing this on your project, think through your BACnet design and how the lighting might affect it. Next slide, please. Finally, not every system is ideal. In this case, it was a constant air volume. Again, I mentioned earlier, you want variable system. Constant means flat output all the time. So this was an example where it was a multi-zone system that all the zones had to be unoccupied before the fan would shut off. Basically, it was a standard office where people showed up around 8 and almost everyone left at 5 because they dealt with the public, so they were done when they left. Schedule would have been more efficient approach. So you really want to look at VAV systems, not constant air, and there's other variable systems of VVT. Those just don't work as well. So you really want a VAV system. You need that variable aspect to really make this effective. Next slide, please. Finally, not all of our projects have looked at integrating with mechanical systems. We've also looked at lighting integrating with plug loads. Again, the idea is you've got an occupancy sensor communicating to the receptacle and turning off so the devices aren't drawing power overnight, saving, in some cases, a fair amount of energy. The Minnesota Department of Transportation struggled with this, and I'm going to kind of give you some lessons learned there. Next slide, please. So one of the challenges they had was user training. So imagine you move into your office and you have a receptacle that turns off on the wall. But I have to tell you all these other things. I have to tell you about, payroll, what your normal job is. Oh, and this receptacle that turns off. So that was one challenge, is that as they had new staff, they kept forgetting, and it was just a constant upkeep of educating. The other reason you'd see is the top left. You can see the controlled receptacle is the top left image. A GFCI is the top right image. They look kind of similar. The bottom image is a quad box. So those are 4 receptacles. Only one of those is controlled, meaning it only turns off when it's unoccupied, yet they all look very similar. So employee understanding and training was a challenge, and it's something to think about if you do plug load integration. Next slide. Another challenge was, look at the numbers that Adam and Kenny presented. Significant energy savings from the mechanical system. While some of these percentages are impressive in the plug load, 68%, the actual energy wasn't as significant. That's because you think about it, the mechanical system uses a lot, the objects are plugged into your wall. So one of the challenges MDOT ran into was like, hey, we're getting a lot of other savings elsewhere, and we're having some headaches dealing with this system, and it's not saving us that much. We'd rather just not use it because we're getting most of our bang for the lighting system. So if you're thinking about doing lighting plug load integration, really try to focus on those high power devices. And moving on to my final slide. The other challenge they had was, in some cases, the plug loads were turning off, the occupancy sensors were turning off receptacles, even though someone was in the building. This is a big variable building where basically on a Thursday night, there's a snowstorm, lots of people working. On a Tuesday night, it's normal, everyone's gone. And so they had no way of controlling the operations, and some of the coverage sensors weren't in the best place. And basically people would be devices would be turning off that they wanted to use. So when you do plug-load integration, you really need to think about your sensor coverage and how it's going to work with your building. Next slide, please. And I'll bring back our moderator, Corey.
Thank you so much, Michael, and all our presenters for their insightful presentations. Before we begin Q&A, please join us over at Slido to respond to our final poll. We can go ahead and transition over to Slido. Cool. So the first question on the roster for today is, when considering integrated controls for lighting and HVAC, plug loads, or other systems, what are your top concerns? And already we see at the top of this list, cost. Yes, these systems are a little bit more on the pricier side, but again, as some of our presenters have mentioned today, that the payback that you get over these do happen over time if the system is installed correctly. So complexity is a runner-up on here. Interoperability, systems may not work together. It's another big one. Ongoing maintenance, and a few others. Cost still at the top of the list. Okay, it's looking good. We're at about 41, so give it just one more second, people to get their answers in. Cost at the top of the list. Complexity next up. Up, evening out a little bit. Great. Now to move on to Q&A. So we have a few questions that came up, a few anonymous ones here. I was at a conference in California recently, and all of the rooms were very cold, HVAC set very low. This seems to be a waste of energy. How can we get operators to keep fresh air coming in, but not make it so cold? It's a very good question. Would any of our other panelists like to take this one?
Yeah, I'll try that one. CO2 sensors can help because then we can, keep the fresh air coming in. Temperatures are an art, and it depends. Everywhere you go is there's different people, there's politics, there's all kinds of stuff. I don't really think there's one answer. I love that Adam's able to have those crazy high set points. If I try and adjust a room above 74, they're screaming and crying. And so there's no bullet fix for this one. But this, now that we have, better CO2 sensors and we're able to control to that, we can at least, keep our air volume correct. And so that could help a lot.
And I'll jump in here too, Kenny. And I should reiterate that those setback temperatures and even our set points, I really think it's because of the radiant heating and cooling. I think it makes such a difference the way it feels in a space, and it's not forced air. And then to answer this question, we actually use dedicated outdoor air system, the DOAS, and I don't know if that's, it took me a while to really figure out how we were getting savings from that, but you can even use them with forced air systems, so you can bring in outdoor air and not mix it with the return air, I believe, to generate some of those savings and keep fresh air coming in to meet your CO2 saving or your CO2 levels and everything like that, while also hopefully reducing some of your HVAC costs.
Sounds good. Okay, on to the next question. To Mr. Hutchinson. you want to go ahead?
Yeah, no, I'm reading through it here. So if as you know, temp ranges are sensitive. I think Kenny just said that. Yeah, especially since half the staff petition to be colder. Yeah, and once again, I think that this really comes for us, and I know not everybody can do this to install a radiant system in their buildings right now. This has been a really hard sell from the beginning, but it was a for us, I think everybody touched on it, Kenny and Michael. It's really communicating and getting engagement from the occupants. There's a lot of things you can talk to people about with comfort, like light levels, heating levels, cooling levels, all that kind of stuff. We really, as an organization, and this came from all the way from the top, honestly, it came from like the CEO at the time, down through the chiefs, down through the managers. I think that really helped a lot in saying, hey, you know what, if you're cold, put on a sweater. Or, we have this building that's supposed to seat about 900 people. If you really want to, you can move to a different space. You can move somewhere closer to the lights. I mean, I know people said that, and people don't actually do it. But yeah, I think occupant engagement is a huge thing, and then I also think the radiant. I know not everybody can do that, but yeah, that would be my answer for that one.
Okay, sounds good. For the sake of time, we'll take just a few more. Again, for Adam, what baseline do you use to measure your savings against?
So for everything that I presented today, that the baseline we use is actually would be a set schedule for everything. So we would use the set points, fixed schedule from 6 a.m. to 6 p.m. And that would be for all HVAC, especially because all spaces would be heated and cooled. Lighting would probably still be tied to the occupancy sensors. So, but you can kind of see that there was a schedule, a baseline schedule in our lighting control system. So that's pretty much what we're using to go as our baseline, is a scheduled approach, scheduled schematic.
Okay, sounds good. Just because I got one more upvote, we'll take this last question from Dan Rogers. Could our speakers share when or how long they anticipate it will take for the energy savings to pay back the additional cost of the advanced control systems?
I'll step in there for a second. So we've done a fair amount of different studies on this. Let's start with the lighting system. Once you add in the advanced LED controls onto the LEDs, it often pushes the payback or cost recovery period for the lighting system, often more than 10 years. It depends on a few variables. We've seen in integrating with the mechanical system, it reducing the payback of the lighting system by 30 to 40%. Many of the integrations that we've done, we looked at about 7, we saw a payback of from just the bits and pieces of doing the setbacks on the mechanical system between about 2 to 3 years. Again, most of these things were small mechanical, or you needed some labor needs and a few pieces of equipment to make the communication work, but you weren't doing any major installs. So in general, for the mechanical integrations, we saw it relatively quickly, and then all that energy, as Kenny and Adam have shown, really helped leverage and reduce the cost of your lighting systems. So together, it's a really good thing to look at. I don't know if Kenny or Adam had similar experiences.
So I'll be honest, I never did the ROI on this stuff. I did it because it was the right thing to do. But what I can tell you is that we've been in a hard push to electrify. We went from direct gas-fired absorption chillers to electric chillers. We then electrified other systems. I've added 300,000 square feet, and I've reduced my greenhouse gas by 50%. I use the same amount of kWh and kW today that I used in 2018. It's because we're not cooling spaces that don't have people. The data doesn't lie. What that ROI is, I don't care. Although Michael, they've been doing all kinds of data on that and showing that stuff. And so that's not the answer you want, but it works.
And I know we're almost out of time here, so I'll jump in and just I'll agree with Michael and Kenny. I think at first it was really hard to tease out the exact part of the lighting controls and what the ROI is. We are doing it as well because it's the right thing to do. We're driving energy efficiency. But from what I can tell and working with HVAC techs and stuff, really the cooling savings is a lot. And I think we're under 10-year payback from what we can gather, the information we can gather. So I wish I had a direct number, kind of like Kenny said, but we don't necessarily. We just see a lot of benefit in it because we know we're probably going to be able to use it in the future to get more energy savings. So.
Okay, sounds good. Thanks you everyone for your questions and to our panelists for their insightful responses. We can go ahead and go back to the slide deck. Got a few more slides to close us out here. Cool. So do you want to be recognized like our speakers? Here we have a few case studies up on the screen. These case studies tell you exactly what the project was about. It gives you a little bit more background information about the project's initial and overall goals, as well as some quick facts and key strategies and outcomes. Next slide, please. Submit for recognition. What are the benefits of actually submitting for recognition? One of them, again, like we just saw, you can have case studies and infographics developed. You can get DOE exposure through social media, emails, and newsletters, featured in industry publications and social media, invitations to speak on your project, like our two presenters have spoken about their projects in today's session, use of ILC recognized logo, and finally, technical resources. Next slide, please. Cool. Better Buildings Fall Webinar Schedule. This webinar is a part of the Better Buildings 2024 Fall Webinars lineup. As you can see, we have a great collection of presenters every Tuesday through the end of the year. Visit the Better Buildings Solution Center to learn more and register. Next slide, please. We hope you'll join us on Tuesday, October 29th for our next webinar titled Tracking Fugitive Inventorying Building Refrigerants and Reducing Leaks. Join this webinar to learn how to identify, categorize, and track refrigerants in building portfolios and strategies to avoid leaks that generate fugitive emissions. Next slide. The Better Buildings Summit. Next, we are pleased to announce dates for the 2025 Better Buildings, Better Plant Summit. The summit will be in the heart of Washington, D.C. from April 30th through May 2nd. In addition to engaging and interactive sessions, attendees can look forward to plenty of opportunities to network with their fellow industry peers and experts. Subscribe to the Summit's email list on the Solution Center to hear the latest on registration, sessions, and more. Next slide, please. And with that, I'd like to thank our panelists very much for taking the time to be with us today. Feel free to contact our presenters directly with additional questions, or if we couldn't get to your questions during the Q&A period. I'd encourage you to follow the Better Buildings Initiative on LinkedIn and X for all the latest news. You can find our handles by their respective icons on the left half of the slide. You will receive an email notice when today's recording slides and transcript are available on the Better Buildings Solution Center. And again, thank you everyone for attending today's webinar.